The James Webb Space Telescope has delivered a revelation that has thrown astronomy into a state of shock. For months, 3I/ATLAS was cataloged and tracked like a routine comet, an icy body from the void, another frozen wanderer making a pass through our system. But Webb's golden mirrors revealed that this was no ordinary visitor. Data showed mass and density that pushed far beyond expectations. The trajectory was not stable, not drifting like dust or rock. It was locked onto a path with Mars, and the clock was ticking. Scientists had been watching its unstable motion for months. Normally, comets shed ice and gas in arcs that cause predictable nudges, small deviations in orbit. Atlas moved differently. Its track across the sky suggested an unseen hand, a guided drift, or a weight so immense that outgassing could not touch it. Inside NASA, ESA, and other agencies, these findings were held close. Fear of public panic kept official statements quiet while the data was rechecked, cross-verified, and debated. But once Webb locked in with its ultra-precise instruments, there was no way to soften the blow. A direct intersection with Mars was confirmed. The implications were immediate. If Atlas continues on its course, the red planet faces an impact unlike anything humanity has ever witnessed. Calculations show that the energy of such a strike would equal millions of nuclear weapons detonating in a single flash. The asteroid that ended the age of dinosaurs on Earth 66 million years ago would pale in comparison. This is not just a cosmic firework. This is an event that could transform Mars into a different world overnight. A crater larger than Olympus Mons is within the range of predictions. That volcano, already the most massive mountain in the solar system, may one day stand next to a scar gouged into the Martian crust by an interstellar body. Shock waves would tear through valleys and canyons. Dust would billow upward into the atmosphere, spread by thin winds across the planet. The climate, fragile as it is, could be altered beyond recognition. Mars, already inhospitable, could become more violent, more unstable, or paradoxically, more alive. The Webb data also hinted at something stranger than trajectory or energy. Along the surface of ATLAS, faint reflections were recorded, signatures that did not align with ice or dust alone. They looked like metallic compounds. Some researchers whispered about structured glints, patterns that seemed too regular to be random. Were these natural deposits of rare metals? Or could they be something else, traces of design, evidence of artifice? The question spread quickly. If Atlas is not simply a comet, then what exactly is it? Mars has always carried the weight of human imagination. From early telescopic visions of canals to modern rovers rolling across ancient lake beds, it has been a planet of stories and mysteries. Now Atlas bears down on it, not as a distant light in the night sky, but as a cannonball of rock, ice, and perhaps more. The unnerving possibility is that this may not be coincidence. Why Mars, humanity's chosen frontier, the planet most often linked to our future beyond Earth? Why here, and why now? Scientists have already put numbers to the timeline. The impact window is calculated within a few years, not centuries. This is not an event to be shelved for another generation. Dust clouds from the strike would be visible from Earth, a glowing wound in the Martian surface broadcast across the solar system. Telescopes worldwide would be trained on the event, turning the sky into a theater of destruction. Inside space agencies, the alarms are already ringing. Plans for manned missions to Mars, ambitions of colonization, projects that carry billions of dollars and decades of investment all stand in the shadow of Atlas. The countdown is real, and no one has the power to stop it. The world now stands at a strange crossroads. The comet that was not a comet is barreling toward Mars. It carries enough energy to remake the planet, enough mystery to rattle scientific confidence, and enough symbolism to remind us how fragile our dreams are against the scale of the universe. The countdown has begun, and every telescope on Earth and beyond is locked onto ATLAS as the red planet waits for impact. Mars has always been a planet of questions, but if 3I/ATLAS does collide, those questions will multiply. The surface would not just shake, it would convulse. A body this size moving at this velocity carries enough energy to rival the most catastrophic events in planetary history. The first effect would be seismic shock waves rippling across the crust. Valleys would rupture, mountains would crack, and regions long thought geologically dead could be jolted awake. Mars, known for its ancient silence, could roar again under the force of impact. Dust would be thrown into the atmosphere in a curtain so thick that sunlight would vanish for months, maybe years. Mars already struggles with dust storms that circle the entire planet. This would be dust on a scale beyond anything yet seen, a choking blanket that would transform the skies. Without a thick protective atmosphere like Earth's, every particle would spread faster and linger longer, darkening the horizon and painting the sun in red haze. It would not just be a storm, it would be a planetary shroud. Beneath the surface lies another secret. Mars hides layers of frozen water, trapped for billions of years in permafrost and aquifers deep below the crust. An impact of this magnitude would melt much of it instantly. The shock heat would crack ice layers, flooding valleys with torrents of liquid water. For the first time in ages, Mars could see rivers rushing and lakes forming across its surface. These temporary seas would not last forever, but even weeks of liquid water on Mars would alter its face beyond recognition. Rovers already roaming the Martian plains could become reluctant witnesses. Imagine Perseverance sending back images of the ground splitting, recording seismic tremors that throw it off balance. Imagine Curiosity catching strange plumes of gas venting from the surface, chemical signatures never before detected. Even orbiters circling above would see chaos below, capturing global dust storms and fresh scars stretching for hundreds of kilometers. For the first time in history, humanity might watch a planetary transformation as it happens. But the true weight of the story lies deeper. For decades, Mars has hinted at life. Methane plumes, seasonal water flows, strange chemical traces, all pointing to the possibility that something lingers below. A colossal impact could break open those hidden layers, exposing reservoirs that have been sealed for billions of years. Microbes, long dormant, might suddenly find themselves thrust into the open. If life exists beneath the crust, this event could awaken it. The implications stretch even further. If microbial life were ejected into the atmosphere, dust plumes could carry it across the Martian moons, Phobos and Deimos, seeding them with organic material. Over time, particles could drift beyond Mars, perhaps even toward Earth. The idea of panspermia, life spreading from world to world, has long been a theory. With Atlas striking Mars, it could become reality. For the first time, humanity might witness life not just surviving, but moving across the solar system. The possibility terrifies some and exhilarates others. Imagine the scientific impact of finally confirming that life exists beyond Earth. Even if it is microbial, even if it is simple, it would prove that biology is not unique to our planet. It would mean that the universe is fertile, that life may spring up wherever the right conditions exist. On the other hand, it raises fears. If Martian microbes rise into space, could they eventually hitch a ride to Earth? Could the fragments of Mars falling back toward our orbit bring not just dust but biology? Questions like these are already sparking heated debate. Amid the chaos of destruction, another irony emerges. The very violence of ATLAS could make Mars more habitable. Greenhouse gases released in the aftermath would trap heat in the thin atmosphere. Melted ice would pump moisture into the air, thickening it for the first time in eons. The dust storms, though devastating, would eventually settle, leaving behind lakes, rivers, and a temporary climate shift. For the first time in billions of years, Mars could warm. This is not the slow, calculated terraforming dreamed up by scientists. This is terraforming by force, an act of nature, or perhaps something more. Seas and rivers could fill the dry basins. Craters could turn into lakes. A planet once written off as cold and dead could flicker with the faintest spark of revival. Was it all coincidence, or was it part of a larger plan? That question now looms over every discussion. If 3I/ATLAS were just another comet, the story would already be remarkable. But the strange signs keep building. The reflective surfaces Webb detected, hints of metallic compounds, and now a trajectory that appears deliberate. Mars, of all planets, is humanity's focus. Billions have been spent to send probes, rovers, and orbiters. Plans for colonies are already underway. Why then does ATLAS seem headed straight for the planet we are most invested in? The possibilities divide opinion. Some scientists argue for coincidence, an alignment of numbers and chance. Others whisper about warning signs, the possibility that ATLAS is not just natural, but intentional. If it is artificial, the choice of Mars makes sense. To send a message, strike the planet closest to becoming humanity's second home. To deliver a lesson, show that our ambitions are fragile. The countdown is no longer theoretical. Webb's data is precise, the trajectory locked in. Agencies worldwide are calculating impact windows and preparing for the spectacle. If it does hit, the event will not be hidden. From Earth, even amateur telescopes would see the plume rising. Entire observatories would track the strike, broadcasting live as Mars transforms before our eyes. Humanity would not only read about planetary events in textbooks, it would watch one unfold in real time. For Mars itself, the outcome is irreversible. Landmarks we have studied for decades, Olympus Mons, Valles Marineris, Gale Crater, may pale in comparison to the new scar carved by Atlas. Future maps of Mars will show not just the features we know, but the aftermath of a collision witnessed by the entire world. Colonization plans, once centered on exploration and gradual adaptation, may suddenly confront a planet that has been reshaped. The deeper question lingers. Is this a natural event or something more? If Atlas carries artificial elements, then its collision with Mars cannot be ignored as chance. Could it be a test, a warning, or part of a design we are only beginning to glimpse? Or is it a random interstellar visitor whose sheer strangeness feeds our fears? Humanity has no clear answer. For now, what we do have is certainty of trajectory. Webb has confirmed the course. The countdown has begun. Every day brings Mars closer to impact. Every calculation tightens the probability. The world watches and waits, caught between dread and awe. As the final approach nears, humanity stands at a threshold. This is no longer just about astronomy. It is about survival, discovery, and destiny. A single object, born in another star system, has come into our solar system and set its sights on Mars. Whether it brings destruction, transformation, or revelation, the event will mark history. The comet is coming, the collision is approaching, and the red planet, long silent, may soon speak louder than it ever has before.